So here are my three teapot models, each with a different shader. The first one was on the left uses Phong shader for illumination. In the center we have a cell shading, Toon shading, and the third teapot uses Cook Torrance method for reflection. There are several parameters that we can tweak for each of these shaders. For example, Phong shader and the Toon shader, so left and middle, are using the same method for the specular light, which is Phong method. So if we change parameter Phong shininess of the material, we will have a different render for the spots. So here it appears to be in a very small area, and if we decrease the value of this parameter, we will have a bigger area. For the Toon shading, we have 3 steps shading, which means that we only have 3 different colors. One that is for brightened areas, one for dark areas, and one for in-between areas. We can see here the 3 different areas. And we can also see the outline of the teapot. To render this outline, we render first time the teapot with only showing the back faces of the teapot. And when we render this object in the vertex shader, I move the vertex position just a little bit along its normal. And then we render the second teapot, this time by rendering the front faces. And as I was saying, we're moving the vertex along its normal. And we do so by using a uniform parameter, so I can easily change the size of the outline. So it's not a perfect solution, but it's easy to implement. Finally, for Cook Torrance shader, we have 3 parameters that we can tweak a little to render different materials. The first one is the fraction of reflectance that is specular. For example, here we only have specular lights because our fraction is of 1, and as I decrease this fraction, we can see more and more diffuse lights and less specular lights until I get to 0, and there are no more specular lights, only diffuse lights. The other parameter is the root mean square slope of facets, which is in a simpler way the roughness of the surface. So for example, here, if I increase this value, if I decrease this value, we can see that it appears shinier and shinier. It looks like Phong shininess parameters. So the area with specular light is smaller, but it's also brighter. And if I decrease its value, we get a larger area. So the final parameter that we can change is the index of refraction of the material. For the air, for example, it's of 1, approximately 1. And here we had the steel index of refraction, which is of 2.5. If we increase this index, we will have more specular light reflected, and if we decrease it, we won't have any more. And now the last thing we can check with our teapots is how they react to the light position being updated, and yep, they're reacting pretty well. So I didn't use the more physically accurate attenuation, which is quadratic. I used a linear and quadratic attenuation. So we can see it pretty well. If I set the light very far away, yeah, we don't see the teapots anymore. And just one problem I had, we can see it very well right now, is Here, where the geometry is a bit trickier, we can see that the specular light is not doing well at all. So I don't know if this is something I could fix by using a pixel shader, but I'll try and look into it.